Good morning, everyone. I am trying video for the first time. I'm sure you're probably doing new things too. So I just thought I would welcome you to online class. And as you see, I've got a piece of paper here. I will be trying to teach you like the chalkboard or the whiteboard. And as we do this, I will also take PDFs of my work and send them to you. So don't worry about taking quick notes unless that helps you, and we'll get going on that after. Another thing is that I would like to ask you to send me questions from your homework, the question numbers, so that I can make a separate video helping you with your homework. And I'll be glad to do that. What I need to do is I need to have that by noon on Monday so that I can publish them hopefully by Monday night. If your homework was due on Monday, then it's still due on Monday. It's just that we're going to have lost a week. So that's the deal. We're going to still have homework. And most of you have answered my quiz/survey. Please do that. That requires that you tell me if you've got internet or not and how much. I think it sounds like most of you have unlimited and that you are able to take pictures of your homework and send them to me. And so that'll be great. I will grade it and send it back. I don't know how well marked it's going to be at this point. I'm still kind of working on that. So that's where we're going. I'm going to start out by reviewing a little bit of what we've talked about in terms of graphing. Now, our graphing situation is based on 2 or 3 different things. The first thing is algebra. So let's talk about the algebra part. The algebra part is where we first of all find the zeros to a function. The second part, we find the vertical asymptotes to a function. The third thing that we tend to do is we tend to find the horizontal asymptotes. Now, horizontal asymptotes, sorry, I'm going off the page. Whoops. Okay, so horizontal asymptotes can be found with calculus, or they can be found with algebra. So this is an idea with algebra or calculus, either one. The calculus maneuver is limits, and it's limits at infinity around page 205 in your textbook. So let's start out talking about those. The second thing that we're going to focus on is the calculus part. The calculus part of graphing, let me say that this is about graphing, okay? The calculus part of graphing is, first of all, finding the first derivative. Once we find the first derivative, we set that f prime, normally called f prime, equal to 0, or we find where it's undefined. That would be where the denominator equals 0, okay? So that's what that's all about. Now I'm pushing the paper up because I want you to see this. Then what we need to do is when we find where f prime is equal to 0 or where the denominator is equal to 0, we call those critical values. So these x values, the x values that we find, are called critical values. What we do with those is we get a number line and we mark the critical values. I'm going to call them like critical value 1, critical value 2, critical value 3. And then we come in between them or on the left or right side of each one, and we find values that we call test values. In that, we plug in the test values into the first derivative. So plug test values into f prime. Now you'll remember from before spring break, what we did with that is if our result was positive, then that implies, this is notation for implies, that implies increasing, means that the function is rising as we read across the page. If it is negative, that implies decreasing. So we mark increasing and decreasing all along here. The important things actually happen at the critical values. So if we have something that increases and then we have a critical value, whoops, there you go. Sorry, I didn't realize you